Good day, ladies and gentlemen, and welcome back to the Inside Science Theory. So today I want us to go through a very important part of chemistry. As a follow-up of what was covered in the previous video. If you have not seen that video, please make sure that you see both those videos that I've uploaded thus far. So in this video, I want us to look at IUPAC naming. So IUPAC is an acronym, quite a long one. I'm not sure if I still remember. Um, some international union of physical and applied chemistry, something like that. I don't know if that's correct, but it's that's not important really. Um, what we need to understand is what we mean when we say, or rather, what is our goal when we do IUPAC naming? So just as the name says, it's IUPAC naming. It's naming all the different compounds that we have under organic chemistry under every homologous series, right? So you must understand that we have what we call a homologous series. Okay, homologous series. And homologous series, you have nine of them that you must know, must remember, do not forget them. You have nine homologous series, right? So what exactly do we mean when we speak of homologous series? When we speak of homologous series, we basically speak, sorry, of some compounds that can be described by having the same general formula, rather, or in which they may differ from a CH2 group. So they must have the same general formula, right? That's what we mean or when we speak about homologous series, right? So what is a general formula? Well, in this video, I just want us to look at the first five homologous series and how to name all of those homologous series, right? So say I have a compound here with one, two, three, four, right? And then I have my hydrogens. Remember, I'm not going to include hydrogens, guys, but just know that they are hydrogens. And in the exam, you must include the hydrogens, right? Or in the any test that you write at school for marks or anything like that, not just the exam, then you must make sure that you include the hydrogens, right? So for starters, I have a simple compound here, quite a simple one. Just a quick question. Since for those of you that have watched the videos I've posted thus far, I'm sorry, for those that have not, please make sure to watch so that you don't get lost in what I'm about to do right now. Right, so notice something. How many carbons do we have here? I have one, two, three, four carbons. Which prefix do we associate having four carbons with? So which prefix basically tells us that we have four carbons? Aha, so prefix but, right? So the prefix but. Okay, so now I want you guys to understand something. So since I have a chain of four carbons with the hydrogens, there is a name for this type of compound, but how does that name come about? When you are naming an organic compound, there are certain things that you must remember. So for starters, please don't forget, listen to this. Don't forget this, right? You must never forget the fact that when you start counting, you must start counting from the carbon that is closest to the functional group, right? But those are things we'll look at as time progresses. But this simple compound that we're looking at right now, let's just say that's compound number one. Very, very simple. Let's name this compound. How do we name the compound? We must first identify what type of homologous series it is. Now, ladies and gentlemen, please listen to me. Because there are single bonds between the carbon atoms, please listen to me. Because we have single bonds between the carbon atoms, this type of compound falls under the homologous series that we call alkanes. Okay? Why do we say it's an alkane? Because it consists of single bonds between the carbon atoms. Right, please don't forget that. Okay, so because of the single bonds between the carbon atoms, we say this falls under the homologous series alkanes. So that's the first homologous series that we're going to be looking at. That is our alkanes. Okay, remember there's nine of them. We're going to look at the first five in this video. Okay, so I have a compound here. We've already identified that it's an alkane. right? Please make note of that, ladies and gentlemen. Compounds with the single bond between the carbon atoms, those fall under the homologous series called alkanes, right? So these are our alkanes. Okay, so since we've identified that it's an alkane, there are very important things that you must know about an alkane. For example, alkanes, I mean, every alkane has the suffix A N E. So what is a suffix? The suffix is what I like to call the surname of the compound. Remember, like everyone's surname comes at the end? Yes, the suffix also comes at the end, right? So for every compound that I have, I must identify the prefix. Guys, what tells me, or rather, what helps me identify the prefix? The number of carbons. Please take note of that. What helps me identify the prefix? It's the number of carbons. What helps me identify the suffix? It's the type of homologous series. That's a very important point. Oh my gosh, let me repeat that. What helps me identify the type of prefix that I'm going to use? It's the number of carbons. What helps me identify the type of suffix that I'm going to have? It's the type of homologous series. So every homologous series that's an alkane, sorry, every compound that's an alkane has the suffix ane, right? This applies to all alkanes have the suffix ane. Okay, so let's name this compound. The name of this compound will be butane. Now, why do I say this is butane? Okay, so butane. So let's see. Let's analyze this IUPAC name. So while the first part of it, the but part, what does the but part give me? The but part gives me the prefix. What determines the prefix once again? The number of carbons. And then I have the last part, which is the ane. What does the an tell me? This is the suffix. What determines the suffix? It is the type of homologous series, alkanes. Anything that is an alkane has the suffix ane, right? So those are very important things that you must remember. So that's the name of this compound, butane. Okay, so these are things that you must not forget, ladies and gentlemen. Please, 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 please. Do not forget this type of compounds, right? But we also have what we call the general formula, right? So what is a general formula? A general formula is a formula that you can use to at least, or rather to identify how many carbons or hydrogens are in a compound, right? So, for example, in an exam or anything, they might give you the name butane and they might say to you, draw the structural formula. How will you know just by looking at the name butane? Well, you must know that already if something is but, it must have four carbons. If something is ane, it must be an alkane. But how many hydrogens are there? Okay, I know about the carbons. I know about the fact that it's an alkane, but how many hydrogens will I have? Oh my gosh. This is where the general formula comes in. The general formula for all alkanes is CnH2n plus 2. So please let me just write this so that you can see. These are subscripts. Sorry, the N is a subscript, H, the 2 is a subscript, the N is a subscript plus 2. Please don't write this. Don't do this. Do not do that. That is so wrong, right? These are all subscripts. But now, what is the value of N, you ask? The value of N, I actually hope you did ask yourself that. But anyway, the value of N is basically telling us about the number of carbons, nothing much. Okay? Cool. So once you've identified the value of N for C, you can just take that same value and try to get the number of hydrogens, right? So for example, let's see. Let's try it in this example. So how many carbons do I have here? Four, right? So that's C, four. Then that's C, sorry, that's H, two open bracket four. Remember now I'm substituting the N plus two. So that means that the final molecular formula must be C4H10. Very important. The general formula gives you the molecular formula. So both of these things work hand in hand. The general formula, the molecular formula, those things work hand in hand, right? So the general formula, it gives you what? The molecular formula. Okay, so this is the molecular formula for this compound butane. But let's see how helpful this is. Already tells me that I have four carbons. Is that true? Yes. But how many hydrogens am I supposed to have? I'm supposed to find 10 carbon. I'm sorry, 10 hydrogens. Let's see. That's hydrogen number one, number two, number three, number four, number five, number six, number seven, number eight, number nine, and number 10. Oh my gosh, I do have 10 hydrogens, right? So the general formula is very important, ladies and gentlemen. Please don't forget, because they will ask for it in the exam at some point. They will say write down the general formula for alkanes or other homologous series that you will see as time progresses, right? Okay. I also want to introduce something different now. Same, we're still on alkanes, guys. Now I have another compound two. So this is my compound two. Okay, right. So, ladies and gentlemen, what type of homologous series does this compound fall under? Check the bonds. One bond, one bond, one bond, one bond already. That tells me that is my alkane. Yes. So I'm looking at an alkane right now, right? Because of the single bonds, right? So that's our homologous series, alkanes. Okay? So that's what we've established that we are looking at alkanes. What do you remember about alkanes? They have the suffix ane, right? But now, we then need to name this compound. Now, there are certain rules that you must follow when you're naming organic compounds, right? So, for starters, you must be able to identify the longest carbon chain. Which one is the longest carbon chain? A very important word I forgot to include, you must be able to identify the longest continuous chain. When we say something is continuous, we mean this is a continuous line. This is a continuous line. This is a continuous. When something is continuous, you can literally draw without lifting your finger. If I had to do this, lift my finger, come back here, and then come. That's not continuous because I had to stop at some point, which was here, lifted my finger, came back to draw this line, stopped, lifted my finger, came back to draw this line. So that's not continuous. When something is continuous, you draw without having to lift your finger. So let's identify our longest continuous chain. It can be this one. Notice how I'm going to draw without lifting my finger. Aha. So there it is. Or someone else could have said it's going to be this one. Notice how I also did not lift my finger on this one. So that can also be my longest continuous chain. But I'm just going to take the straight chain for safety purposes, right? Right. So now, the name of this compound will then be determined by everything that we're going to uncover right now. Just bring this a bit down. It's too close to the previous one. Okay, right. So this is what we have. So the longest carbon chain consists of how many carbons? That's one, two, three, four. Already, when you see four carbons, what prefix are you thinking of? Ah, bute. And it's bute, right? But since it's an alkane, what suffix are you thinking of? Ah, ane. Okay. But that doesn't mean the name of this compound is butane. Please, something comes in between here, but we'll see what that is. Okay. So, what else do you notice about this diagram? I mean, this compound. What do you notice? What's this different thing that you're seeing right now that just shouldn't be there? Okay, not that it shouldn't be there, but it's there, but it's something unique. What is this? Ah, the side chain. The side chain. What do we call the side chain again? Yeah, boy. This side chain is called the methyl group. Aha. Now, ladies and gentlemen, please remember when you are naming organic compounds, since you have a methyl group as your side chain, you need to make sure that you name your compounds in alphabetical order. That is, when you're naming in alphabetical order, it must be a thing, Yoguti. If I have a side chain, right? When does the alphabetical order rule apply? Sorry, the alphabetical order rule applies when you're looking at substituents. Substituents. So the alphabetical order rules applies when you're looking at substituents only, right? So that's very important. Substituents. So for example, since I have butane, right? This is your what is this? Your rule on alphabetical order will not apply on butane because this is not a substituent, it's the actual name of the compound, the chain, rather the longest chain. But since now there's a methyl group, we must include the methyl group in our IUPAC name, right? So how do we write down this name? The name of this compound will be 3 dash methyl. Okay, no, don't be that. Let me fix it. One, mm, mm, 1, 2, 3, 4. Okay. Right. So the name of this compound will be 2 dash methyl butane. Okay, so that's the name of the compound, 3-methyl butane. Notice how I didn't use a capital letter here, guys. Just like you do in English, you do in physics as well. You don't put a capital letter in the if a letter is in the middle of other letters, right? Like you can't have um the name money like this. So you can't have small n and all of a sudden you decide to have a big E and then Y. Okay, right. So let's see. Wow, let's analyze this name. So we should know by now that if we have BUT, that tells us the prefix, that tells us how many carbons are in the longest chain, right? It tells us how many carbons are in the longest chain. And then the ANE is a suffix. It tells me that I'm looking at an alkane because for every alkane, the suffix is ANE. And then the methyl group tells me that I have a methyl group. But what does the 2 tell me? The 2 tells me where the methyl is found. So the number 2 tells me that the methyl group is found on carbon number 2. Do you guys get that? The methyl group tells me that my carbon is on my what is this? My methyl group is on carbon number 2. That's what it's telling me. Exactly that. My methyl is on carbon number 2, right? So that's the name, 2-methyl butane. But notice a dash. What does this dash do? Guys, please don't forget. Note this thing. You separate numbers, you separate one number from another number by using commas. But you separate a number from a word by using dashes. So that's a very important thing to remember. I'm going to remove this. You can just pause and write it down. Okay. So notice how I used a dash to separate a number from a word. That is the general rule. You must never forget that. You use numbers to separate what? Words from, sorry, you use dashes to separate words from numbers. Don't write something like this, 2-methyl butane. This becomes completely wrong because you are missing a dash in between the number and the word. So that's a very important thing to remember. So please don't forget that, guys. It's very important. Okay, so that is the name of this IUPAC. That is the IUPAC name of this compound. Okay. Um, let's move on to the next one. So I have another compound here, which is C methyl. Okay, right. Let's quickly just fill this in. Okay, so notice something. In this compound, we have to identify the longest carbon chain first, right? So let's do that. The longest continuous chain. That is going to be this chain right here. Okay, let's just say someone else decided to go this way. Is that the longest carbon chain? Well, how many carbons does it have in the longest chain? We have 4 carbons. Okay, that's the first option. And then let's look at the other one. This one here. It's also long and continuous. That's 1, 2, 3, 4, 5, 6, 7 carbons. Okay, and then I have this one here, which is 1, 2, 3, 4, 5, 6, 7, 8. So this other one has 8 carbons. So which one has the longest carbon chain? Which one has the most carbons in the continuous chain? This one with 8 carbons, right? So that's the longest one. So guys, you must do the same thing that I did here. If you're not sure about which one has the longest carbon chain, write down all the possible continuous chains that you think would work, and then compare which one has the longest, which one has the most number of carbons. Just do that for yourself if you're not too sure in an exam. Trust me, it's going to be very helpful. Okay, so now that we've identified our longest carbon chain, we then ask ourselves, how many carbons are in the longest carbon chain? That's 1, 2, 3, 4, 5, 6, 7, 8. Which prefix do you associate with 8? Ah, you guys are smart. Oct, right? But now since it's an alkane, we have the suffix ane. Okay? But now we need to then see our two new friends here, our substituents. So I have substituent number 1 here. Um, Substituente numero uno and substituent number 2. Right. So what do you notice about substituent number 2? What type of a substituent is this one? Aha, yes, it's a methyl. And then which one is this one? Notice the number of carbons. Ah, yes, ethyl. Okay, so we have a methyl and an ethyl functional substituent. Okay, now what? Now that we've identified the substituents and the longest chain and the prefix and the suffix, we can then name our compound. But there must be certain rules that must be followed. Guys, I think I mentioned it in the second compound there. When you are naming these things, what's important? You use dashes to separate numbers from words. You use commas to separate numbers. So you use dashes to separate a number from a word. You use commas to separate a number from a number. And you use, when you're naming your compound, you must have it in alphabetical order. But the alphabetical order rule only applies to substituents, right? So which substituents do we have thus far? We only have 2, which is our ethyl and our methyl, right? So between M and E, which substituent should come first. How do you know that? Look at the letters. Remember alphabetical order. Between M and E, which comes first? E, right? So this is the IUPAC name that we're going to have. The IUPAC name of this compound will then be, oh, sorry, let me number these things. So that would be number one, number two, number three, number four, number five, number six, number seven, and number eight. Okay, so the name of this compound will be, now guys, please name it with me. Which compound, I'm sorry, on which carbon is my ethyl found? On carbon number 5. Yes. So that should be 5 dash ethyl. Notice how I'm using dashes to separate words from numbers, right? And then I'm going to include another dash because I'm going to have another number. So it's 5 dash ethyl dash. Where's my methyl on carbon number? 3. So it's 5 dash ethyl dash 3 dash methyl. Do I need any more dashes? No, because I'm not going to include any numbers anymore. Dash methyl octane. And that's the functional, and that's the IUPAC name. 5 dash 5 ethyl 3 methyl octane. Right. So that is our functional group. Sorry, that is our IUPAC name. So guys, remember these roles that I'm telling you. Guys, everything I'm saying right now, please take note of it. It's very important. It's very important. Trust me when I say that. So now we will then say, okay, this is our IUPAC name. Let's quickly analyze the IUPAC name. The number 5 tells me that my ethyl is found on carbon number 5. The dash tells me that I'm separating a number from a word, right? And the number 3 tells me that my methyl is on carbon number 3. And the oct tells me that I'm looking at the longest chain being 8 carbons. And then my substituent, sorry, my prefix is ANE because I'm looking at an alkane. Okay. Um, that was nice. Right, so let's look at a different compound. Last compound under alkanes. Okay, so we have this compound. There was some deafening silence there. Okay, so we have this compound here, right? Right, so this compound, whew, quite a bulky one here. But let's see. Same conditions apply. We need to identify the carbon chain that's the longest, right? So let's see. I have this one here. Okay, this one is obviously not the longest. It only has 3 carbons. Let's see this one. This one has how many carbons? One, two, three, four, five, six. So we have 6 carbons. Okay, let's look at other options. Okay, let's go this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have carbon equals to 9. That could be our longest carbon chain, hey? And then we have this one here, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that one will win the prize and will then be considered our longest continuous chain. Okay, right. So we've identified our longest continuous chain. So because of the number of carbons, that means we're looking at the prefix dec. Yes. And because it's an alkane, we're looking at the suffix ane. And now, from here onwards, we are then going to say, okay, um, what then am I going to look at? I'm then going to say, how about I then take, sorry, my new focus, I'm so sorry. The new focus is going to be on the substituents, right? So how many substituents do I have? Well, notice how I have a difference in substituents. So I have my first one here, I have my second one here, and I have my third one there. All those three substituents that I've given you thus far, what are they? What's so common about them? Yes, they are all methyl substituents. All of them are methyls, right? All of them are methyl. But let's look at the other one. What type of a substituent is this one? This one would be a propyl because there's 1, 2, 3 carbons. So this is a propyl substituent. If you don't know what any of this means, please make sure to watch the previous videos. Okay, so that's a propyl substituent. So now the naming needs to be very important here because now we also need to consider what again? The numbering, the dashes, the commas, and all of that. Commas will then have to be very important here. Why do I say that, guys? Notice something. How many methyls do I have actually? Notice how many methyls I have. I have three, right? And what's the prefix for when I have three alkyl groups? Ah, tri. Yes, the prefix must be tri. So now I have three methyl groups, right? I want you guys to understand something. When you're naming organic compounds, prefixes like tri do not take any preference. Like we do not consider the prefixes like tri when we're looking at alphabetical order. Prefixes like tri, di, tetra, those do not take any kind of existing preference. Please don't forget that. We do not consider them when we are looking at alphabetical order. So what do I mean? Let me write down the IUPAC name of this compound. Let's do it together. So how many compounds on the longest carbon chain? Let me write that down. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, so let's write the name. So on which carbon is my first methyl found? On carbon number 2, right? The second one is on carbon number 4, and the third one is on carbon number 5, right? But now question, if I want to write these in alphabetical order by looking at the substituents, between methyl and propyl, who comes first? Aha, the methyl, right? Because P is A, B, C, D, E, F, G, H, L, M, N, O, P, Q, R, S, T, U, V, W, L, Y, Z. Right? Right. So the M comes first. So the name of this compound will be 2.4.5 dash trimethyl. Now, why do I say 2.4.5? Because these numbers 2, 4, and 5 tell me where all my methyls are found. The first one is on number 2, the second one is on number 4, and the third one is on number 5. Right? Please make sure that your numbers are always written in ascending order. Don't write something like 5, 2, and 4. No, they must be in ascending order. Right? So that's my IUPAC name thus far. I'm not done. It's 2.4.5. Notice how I'm using commas to separate numbers, right? But I'm using a dash to separate a number from a word, right? So that's 2.4.5 trimethyl dash um, 6 dash propyl dash sorry, 6 dash profile. I'm not going to have any other numbers. So this then becomes decane. So notice something, ladies and gentlemen. In this case, we all know that according to the alphabet, T comes before P. So why did I not write the propile first? Because of what I just said. When you're counting and you're writing things in alphabetical order, the prefixes do not take any preference. Please don't forget that. This TRI, we write it in the IUPAC name, but we don't consider it when we are trying to check which one comes first, which one is in alphabetical order. When you're looking at alphabetical order, the prefix do not take preference. That's why the first thing I looked at was the M in the word methyl. Right, so that's our IUPAC name. If you have any questions as to how I named that one, please do not be afraid to ask. So let me give you the final one. This is for you guys to name. This is just for you, a nice snack for you before we move on to the next one. This one you're going to do on your own. You're going to send your answers in the comment section if you feel that you want to see whether you're right or not. Hmm, I like this one. Okay, so this is a compound for you guys to name. Okay, then you can send your answers in the comment section. I hope you guys have fun with this one. Okay, and then now I want us to move on to the next one, right? So the next one would be your alkenes, right? So this is when we are naming alkenes. So alkenes have the general formula CnH2n, and yeah, we just leave it at that. And then what else is special? Oh, the suffix for alkenes, or the surname as I'd like to call it, is your ene. So this is a suffix, right? And what's also special about this? How do you identify an alkene? Alkenes have double bonds. Okay, so let's have a look at the first IUPAC name. Right, so the first IUPAC name is what we're going to be looking at now. So now I have a compound here of alkene, right? And now I'm required to name this compound. Hmm. Well, let's just make it a bit extra fun. Okay, right. So let's try and name this compound. First and foremost, what's the first thing you must do? Identify the longest carbon chain, right? So I'm gonna go 1, 2, 3, 4, 5, all the way there. How many carbons? 1, 2, 3, 4, 5, 6, 7. And then if I decide to go all the way down, this is gonna be 1, 2, 3, 4, 5, 6. Okay, so the one with 7 carbons is the longest, right? So now that I've identified 7 carbons, what's the prefix? Hept, right? What's the suffix? Since we're looking at a double bond, This is our double bond. We've already identified the double bond. We know that this is an alkene. So what is our double bond? So what's our prefix? Sorry, the suffix is ene. Okay, now let's name this compound. What do we see that we also need to consider? The substituent, right? But what type of a substituent is this one? What's the name of this substituent? This is the ethyl substituent, right? I really hope you guys are seeing the trend in this. Okay, so now the name of this compound will then be, let's see, let's try and understand the name of this compound will then be 1, 2, 3, 4, 5, 6, 7. So that's 7 carbons, and I have an ethyl on carbon number 1, 2, 3, 4, 5, 6, and 7. Now, before I write down the IUPAC name, guys, it's very important that when you are writing down the IUPAC name, you need to consider another rule that says when you count the number of carbons, mind you, this rule does not apply on alkanes. It applies on every other homologous series, but not on alkanes, right? However, oh, sorry, it actually does apply on alkanes when there are certain substituents. But now, the rule says when you start counting the number of carbons, you must start from the carbon closest to the functional group. So the double bond is a functional group for the alkenes. All right, so I'm just gonna write that down. For the alkenes, the double bond is a functional group. So I need to start counting from the carbon closest to that. How do I know if a carbon is closer to a functional group? The functional group must be located at a carbon that's a smaller number, or rather at a carbon that has a smaller number used to denote the location. Maybe let me reiterate. How do I identify if something is closer to the double bond or to the functional group, rather? You need to look at the carbon. When I say something, when I use numbers to indicate locations? Yes. The number that you use to indicate the location of a double bond or any other functional group must be very, very small. It must be literally the smallest number. For example, if I decide to count from the right to the left, what do you notice? Sorry, from the left to the right. Notice that my double bond is in between carbon number 1 and carbon number 2, right? So basically it's bonded, sorry, the double bond is found on carbon number 1, right? It's found on carbon number 1. But if I come from right to left, I go 1, 2, 3, 4, 5, 6. My carbon is on my double bond is on carbon number 6. Which number is small? Big 6 or 1? 1, right? So I need to take the small number. So the name of this compound will then be 4 dash ethyl dash. Are there any other numbers? No. So no more dashes. So 4 dash ethyl hept dash 2 in. Not 2 in rather, but 1 in. Hept dash 1 in because it's found on carbon number 1, like I said. Hash, so it's 4 dash ethyl hept dash 1 in. Right, so that's what we have, the IUPAC name. I'm about to say something very important, ladies and gentlemen. Please journey with me. When you are naming organic compounds with double bonds, triple bonds, um, and other homologous series that we're going to be looking at, you must make sure to include the location of the functional group. Like in this case, it's on carbon number 1. I need to make sure that I include that location. Why? You include the location if and only if the double bond can be shifted around, can be moved around, or the double bond can be put on different locations, or the double bond can be put on different carbons, right? So if I can take this double bond and I can just wake up on one random day and I decide to put it here. Notice how the double bond could easily shift from carbon number 1 to carbon number 4. Because that is the case, I need to be specific when I'm writing down the IUPAC name. I need to be specific to the marker that this double bond is found on which carbon. Why is there need to be specific? Because of the fact that my double bond can shift around. It can move around from different carbons, from one carbon to another. Hence, I need to make sure that I specify the location when I'm writing down the IUPAC name. That wasn't clear enough. Let's look at this example. So I have 1, 2, 3. Okay, so in this compound, the longest carbon chain will be this one, right? So how many carbons are in the longest carbon chain? 3. So this tells me I'm looking at prop, right? And also tells me that since I have a double bond here, I'm then looking at um what is this compound? Sorry, an alkene, right? And it has the suffix ene. Right all, right all, right all, right all, right all. Okay, so how do I name this compound? The name of this compound will be 2-methyl um propene. Now, why is it that I decide to not specify the location by saying prop1ene? Because, like I said, you specify the location if the double bond can move around. If the double bond can be on more than one location, more than two locations, rather. Notice how on a random day I can wake up and decide to put in the double bond here. At the end of the day, the double bond is still on carbon number one, regardless of where I just okay. It's still on carbon number one, right? Regardless of where I put it. Because if I put it on the right hand side, that means I need to start counting from this side. So then this then becomes carbon number 3, number 2, and number 1. And then this still becomes prop 1 in, right? So for as long as the double bond has no other place to go to, you don't need to specify the location. If a double bond has no other place to be, has no other carbon where you can put it, you don't need to specify the double bond's location, right? Right. I hope that was very clear. Okie dokie. I think now we can look at let's see. Right. I really hope that was very clear, guys. Most of the things that I wanted you guys to know have been done on the alkane examples. So I just want us to move on to the alkynes, right? Please, guys, the important things that you must never forget. Use commas to separate numbers, dashes to separate numbers and words. Alphabetical order. Prefixes of substituents do not take preference when you're trying to identify the alphabetical order. Such things are very important, guys. Okay, now then going to look at alkynes. So alkynes have the general formula CnH2n minus 2. Alright, so I have a compound here. Oh, and also what's so special about them? The surname or the suffix of of this homologous series is YNE. Okay, so what's special about them? The fact that they have triple bonds. Right, so I have an example here. 1, 2, 3, 4. Okay, so what's the IUPAC name of this compound? Let's identify the longest chain. The longest chain is this one, obviously. How many carbons are in the longest chain? We have 4, so that tells me I'm looking at the prefix but. And since I have a triple bond, I'm looking at the homologous series alkyne. What suffix do I associate it with? Y and sorry, Y and E, right? Okay, now, question. Can my triple bond move around? Yes, I can put it here or here, right? So I need to be specific with with the location of the triple bond when I write down my IUPAC name, because I can decide to put it here or I can decide to put it there, right? So it can move around. It has different it has more than two locations where it can be placed, right? So it's some things that you need to focus on, guys. Some things that you must pay attention to. Okay, so what will the name of this compound be? So the name of this compound will be but 1-ine. Why is it but 1-ine? Because on carbon number 1, I have my triple bond. Notice how I started counting from the carbon closest to the functional group. This is our functional group. The carbon closest is the carbon with the smallest number, and that's carbon number 1. If I started from left to right, I was going to have carbon number 4. And now, I'm sorry, I was going to have carbon number 2. And carbon number, not number 2, sorry. I was going to have carbon number, I was going to start from the left to the right, right? So it would have been 4, 3, 2, 1. So I'm going to have to compare carbon number 2 and carbon number 1. And obviously, carbon number 2, sorry, carbon number 1 would be the one that is closest because it has the smallest number. Right, so that is but 1-ine. Right, for alkynes, but 1-ine. Okay, different example, different compound would be your, let's see. Um, okay, let's look at a different compound. Let's look at, oh, whoa, 1, 2, 3, 4. Okay, so let's look at this compound. Looks like a nice one. What's the first thing you do? Start identify the longest continuous chain. So that will obviously be this one. If you don't trust me, you can check. Okay, by comparing the other parts that one can decide to take, right? Okay, so we've identified the longest carbon chain. So what now? Well, that's carbon number 1. That's number of carbons. That's carbon number 1. 2. Why did I start counting from the left? Because that's the carbon closest to the functional group, right? In fact, let me do this for the sake of comprehension. So that's carbon number 1, number 2, number 3, number 4, 5, 6, and 7. Okay, so what's the name of this compound? First and foremost, we've identified the longest chain. So what is our prefix? Hept, because the longest chain consists of 7, so that's hept. And then we're looking at a triple bond, so we know this is an alkyne with the suffix Y-N-E. And then now, what else do we notice? We can then say from here, I need to then identify my substituents. My substituent will be this guy here. What's the name of that substituent? The methyl substituent. Right. So now, also another very important thing, guys, when you start numbering, your functional groups always take preference, not the substituents. Substituents like your methyl, your ethyl, your propyl, those ones do not take preference. They're not dominant. So you don't consider them. They come after. We need to focus on the functional groups when we start counting, right? So notice how I counted from the left to the right, because number 2 is bigger than number 3, right? Ha. However, now that I've done that, I then need to now name my compound and say, the name of this compound will be, notice how I have two triple bonds, right? I have this triple bond there, and I have this triple bond there. When you have two things, what prefix do you think of? Aha, di, right? So that's the prefix you need to consider in your mind. So now this is what the name of this thing will be. The name of this thing will then be um let's see. Okay, so that's 5 dash methyl dash. Oh no. Okay, I just noticed something. What did I notice? The longest carbon chain, this is a very important rule that I forgot to also mention. The longest carbon chain must include the functional groups, all the functional groups. That's very important. The longest carbon chain must include all the functional groups. That's very important. It's a very important point. I forgot to mention that. The longest carbon chain must include all the functional groups. So that one cannot be my longest carbon chain because it doesn't contain all the functional groups, right? So to fix this blunder, the longest carbon chain will then be this one here, right? Then the counting will also have to change. So this will have to be carbon number 1, number 2, number 3, number 4, and number 5. And then we have the rest, right? Cool. So that's what we have now. Right. So what do you want to talk about? Okay, so let's see what we have here. Now, what do I notice? To name my compound, what do you guys notice? Notice that now the substituent has changed. The substituent is now our propyl group. Not sure if you guys can see that. 1, 2, 3. Remember, it's a side chain. Once I've identified the longest chain, anything that's not in the longest chain is a side chain, right? So this is our side chain, and this is the propyl group. Terrible handwriting there. So what will the name of this compound be? The name of this compound will be 3 dash propyl. What is the prefix? Since I have 5 carbons in the longest chain, the prefix is pent, right? So this is 3 dash propyl. Oh, I just wrote propyl. 3 dash propyl pent dash 1.3 ine. 1.3 um diine. And that's the name. So notice how, let's analyze this name. The 3 here tells me that my propyl is found on carbon number 3, as you can see. The pent tells me that I have 5 carbons in the longest chain, guys, please. And we are talking about the longest chain, okay? And then the 1.3, these numbers tell me that these two functional groups here are found on which carbons? Remember, I have two functional groups. I have two triple bonds. One is found on carbon number 1 and the other is on carbon number 3. Hence, this is 1.3. Di tells me that I have two alkene functional groups. And then the Y, sorry, not alkene, but alkyne. And then the YNE will then say to me that we have an alkyne. Right, did I give you guys a general formula for this? Yes, I did. So let's test the general formula to see if it works on this compound. The general formula here is CnH2n minus 2. How many carbons do we have in total? We have a total of 1, 2, 3, 4, 5, 6, 7, 8 carbons. So that's C8, and then that's 8. That's 2 times 8 minus 2. So that's C8H 14. So let's see if that's true. How many hydrogens do I have? I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Something is wrong. There's a carbon with more bonds than it should actually have. Which one would that one be? Let's see. Aha, it's this one here. Right, so this is 14. C8, H14. Okay, so these are all the IUPAC names, not all the IUPAC names you should know, but there are fundamental things that you must remember when it comes to IUPAC naming. And I've mentioned a few of those, if not all of them. So please do not forget these things, guys. Do a lot of practice on these things. More practice works better, right? They say practice makes perfect, but I believe in perfect practice makes perfect. So we can then work with different examples, and at the end of the day, with more examples that we work with, the easier it becomes to understand, or rather to comprehend all these things, right? I really hope everything that we've covered thus far was proper and understood. But from me to you, I shall leave you and see you in the next video. Goodbye.